Hi, I'm Amy Schiebel. I'm a science professor at Edgewood College in Madison, Wisconsin, and I direct our Office of Science Outreach. Sorry about the bad lighting for the video, but with 5 people working from home, there's not many rooms to go to, and I refuse to video from the bathroom. You can thank me for that. We've just finished up the Easter holiday season, and for some reason, Easter is associated with eggs. I don't quite understand all of that, but I'm sure somebody does. So you might have some extra eggs laying around your house, and if you have 1 raw egg and some corn syrup and some water, you can do this next experiment. I like this one. It's multi-day, and it's great because it's good for students of just about any age. So if you have smaller children, you can be making observations. There's a lot of smells and feels that go along with this experiment. If you have slightly older children, you can be thinking about some other science concepts of osmosis and diffusion. So diffusion is something that we're all keenly familiar with. If you've ever put something in a garbage can that started to rot and smell bad, you lift the lid. If you're standing close to it, whoo, you can smell it right away. All those molecules that were very concentrated in the area of the rotting piece of food start to diffuse. They start to move from an area where they were highly concentrated to an area that has lower concentration. If you're standing close to the source, you would smell it before somebody who's standing quite a ways away. And for you, it would probably smell worse because you had more of those molecules, and as they start diffusing out through the rest of the room, they are in a lower concentration. Osmosis is something that's very similar, but it's across a membrane. So we'll talk about that a little bit more as we start doing the experiment. The first thing we need to do is remove the shell. Immediately under the shell is a little thin membrane that needs to stay. Luckily, the shell is made from calcium carbonate, which dissolves easily in a weak acid. Vinegar is a weak acid, so if we put our egg in vinegar and let it sit for a while, the shell will dissolve. Here you can see it bubbling. That means it's working. I let the egg sit in the vinegar overnight, and now we're ready to take it out and see what we've got. So pull the egg out. You'll feel it feels kind of big and rubbery. We're just going to rinse off that vinegar, and still left on there is a sort of a fine powdery soft residue of the shell that's not all gone. So you want to very gently rub that off. Here you can see it. You want to get down to that clear membrane. So just sort of work on removing that. If you rub it lightly underwater, it will come off. While we're working on that, let me tell you a little bit more about osmosis. So if we have a high concentration of something on one side of a membrane and a low concentration of that same thing on the other, if the molecules can move across the membrane, they are going to diffuse until they're evenly distributed across the two. So here, that little egg membrane, there we go, all nice and clean, is what the water is going to move back and forth across. And in this one, the water is what we're using. So I'm going to put the egg in a clean container and now cover it with distilled water. If you don't have distilled water, that's fine. You can use tap water. Now, the concentration of water molecules in that liquid water is very high. It's not quite as high inside the egg because there's all the other egg things that are inside that. So our prediction would be that the water molecules, if they can cross that membrane, will move from the liquid water on the outside into the egg. As we look at the egg the next day, we have some evidence that that's exactly what happened. The egg is very large and turgid. If we compare it to just a regular egg, you can see that it's gotten a lot bigger. We could actually measure the water before and after. That would give us something more accurate. So now what we want to do is see if we can get the water to move back out of the egg. So we have to use some kind of a liquid that has a low concentration of water molecules. And what works really well for this is just plain old corn syrup. So now put that egg in a container and cover it up with corn syrup. If in fact the water can move out like we suspect that it will, we should be able to see some kind of evidence for that pretty quickly. And it does move quickly. We can see that the egg is shriveling. It's getting smaller and smaller until what we're left with is something that is no longer big and turgid and round, but quite decreased. So now when we pour off the liquid, you can see that what's coming off is very runny, like water. And it's not until about now that all the corn syrup is coming out of that. Again, we could have measured those amounts before and after if we wanted to have a little more practice with measurement and get more accurate data. But what you can see there is an egg that looks very different from what it did when we first put it in. So a lot of the water has left that egg and now went into the cup that we have just thrown away. So now the question is, can we put the water back in again? Well, let's see if we can. So I'm going to put that egg back into a clean cup, and let's try putting some distilled water back on it and see if we can move that water again from the liquid there on the outside, if those water molecules will move by osmosis into that egg. And sure enough, that's what happens. We have our nice big rubbery egg back again. You can keep doing this, moving it back and forth until it starts to smell. You can try using other kinds of liquids and experiment with what will and what will not move across the membrane. So, have fun with your naked egg and come up with all kinds of your own experiments.